Okay, this getting ready for calculus video is on complex fractions. And so we're going to look at a couple of different types, but before we look at those types, in each of these little boxes are just simple reminders if you need them about how to add and subtract fractions. Just a reminder that you have to get a common denominator, multiplying fractions. And then dividing fractions, we need to change it to multiplication first. And then it's really just like a multiplication problem. So we're going to assume already that you're proficient with this. And so when we talk about a complex fraction, we really just need to know how to handle that and basically make it down to a more simple fraction so that you can handle it and simplify it. Okay, so the type one that I'm going to call it here, I said it looks like this. Okay, so think that you have one fraction on top and one on the bottom. So we have like a over B, and then this is over C over D. So we can see that here. This is like one fraction on top, one fraction on the bottom. Now, this really just means divided by. So it's just this fraction divided by this one. So we are going to write it like that. Okay, so we have the first fraction, which is 25x over 2x minus 10. And this really just means divided by the second fraction, which is 5 over 3x minus 15. So if we can rewrite that, then it looks a lot more simple. And so just like we set up here, if you have a division, you'll just turn it into multiplication. So we're going to change this one time again where, and a lot of students I've heard say keep, change, flip, where you keep the first fraction, change the sign to multiplication, and then flip the second fraction. Okay, so now what looks like maybe a more complex fraction, as we call it, it's really just a multiplication problem. And so to handle a multiplication problem, we're going to cancel any common factors from the top to the bottom. So we can continue on down here. I'm going to factor everything completely. So this is going to be over a 2 times a x minus 5. And then here we're going to factor out the 3. And then we have a 5 here. Okay. Now, remember, you can write it as one fraction. So you can think of this as one numerator and one denominator. So as long as you cancel from the top and the bottom, we can do it like this. So x minus 5 is a common factor. Also, 5 and 25 both have a common factor of 5. So we can divide each of those by 5. Okay, so technically that would be a 1. And now you can just go straight across the top. So you have a 5 times a x times a 3, which is a 15x. And in the bottom, all we have left is a 2 or a 2 times 1. And so this is going to be our simplified answer. And we will leave it like that. Now, those ones are the type 1s. And so that's the procedure for those. So if we go down to the type 2, these are going to look a little more complex of a complex fraction, if you will. So you still have a numerator and a denominator. However, in the numerator, instead of just a single fraction, you actually have an operation of fractions. So there can be an operation of fractions on the top, an operation of fractions in the bottom, or in both. Okay. Now, this is my preferred method, method one, for the most part. But sometimes you might want to do a method two. So I'm going to show both methods here. So the first method is to eliminate the fractions. And to do that, you want to look at all of the denominators that you see on the smaller fractions, I guess you would say. So you've got a 9x, a 3x squared, a 3, and an x. And what we want to do is we want to find the least common denominator of those four denominators. So that LCD, or least common denominator, would be a 9x squared. So what we do after we identify what that is you want to multiply each of those fractions by the LCD. So it's going to look something like this if I were to really write it out explicitly. Okay, so that's going to be 9x squared times that first fraction. And then we're going to do 9x squared times the second fraction on top. And then all of this is going to be divided by, so we'll have 9x squared times the fraction there on the bottom, which is just 5/3. And then once again, you have a 9x squared and times the last fraction, which is a 5x. Okay, some students find it helpful to put this over 1, so you can see clearly that 9x squared is really the numerator. So we can now simplify this. So this looks a little complicated if you write it out like that, but this is just to be very clear that that's what I'm doing. But once you get faster at it, you don't have to write it out so clearly. So you can see the nines will cancel and that x cancels with one of those. So this first term just ends up being 9, I'm sorry, x times the 10, so 10x. All right, continuing on. The next one, the 3 will cancel into the 9, so that's going to become a 3, and the x squareds cancel, so we're going to say leftover is just plus 30. And the bottom 3 will cancel here. So you have a 3 times the x squared times a 5, or 15x squared. And then last, this x goes with one of those. And so you have a 9 times a x times a 5. So that's going to be a 45x. Now, it looks complicated, but look how simple now the problem looks. So we can factor out a common factor. On the top, it's 10. And on the bottom, the common factor would be a 15x. And so we have an x plus 3. And then you can just finish this off because those cancel. And then 10 and 5 can both be divided by 5. So this really is just going to be simplified down to a 2 on the top and a 3x on the bottom. And so that is method 1, which is eliminating the fractions. So usually once you get good at it, you can do it pretty quickly and with less error. So you want to practice it. But the second method is to actually get a common denominator. In other words, you're going to add the top fraction and the bottom fraction. And so you're going to make it look like that type 1 fraction that was up above, where you have a fraction over a fraction. Okay, so method 2 is really to kind of turn it into a type 1. So we need to do the same thing as far as we need to find the least common denominator. So that's still going to be 9x squared. But now what we do with that 9x squared is every one of these little fractions gets to have a 9x squared as the denominator. So if we go ahead and kind of set up the structure of it, we just need to figure out how to rewrite all of those numerators. So this one we multiplied by an x in the bottom to get to here. So we're going to multiply that 10 also by an x. For the second one, we're going to multiply the top and bottom by a 3. For the next one on the bottom, we're going to multiply by a 3x squared. So that's going to be 15x squared. And then finally, for the last one, we can multiply the bottom by a 9 and an x. So that's going to give you the 45x. So if you look, all of these really are the same as what you ended up with over here. But now that you wrote it with the same denominator, you can write this fraction as one single fraction. And so now you can see that this is more of a type 1 problem where you just have fraction over fraction. So we know that that just means if you kind of jump to it, right? If we skip writing this as division, we just keep the first one and then you're going to flip and multiply by the second one. So we can go down here and say that this is really going to be 10x plus 30 over 9x squared times 9x squared over 15x squared plus 45x. And then you can cancel. And then now we end up at the same step that we had in the first method, right? The 10x plus 30 over the 15x squared plus 45x. And so, of course, you would just kind of pick up right there, and then you would end up with the same answer here. So we would factor out the 10, factor out a 15x, and simplify. And so this is going to be 2 over 3x. So they match. You get to the same spot. You just get there a different way. So you can either get a common denominator, turn it into a type 1 problem, and then do the keep, change, flip. Okay, or you can multiply every term by the LCD and then just start out with a more simplified fraction. So take your pick. You can know both methods, but you definitely want to practice so you become proficient and eliminate any error.